Now, heat of combustion. Okay. Let me see here. Heat of combustion basically is the heat given off when a specified amount of the substance, typically on a 1 mole basis, reacts and burns in the presence of oxygen. All right. So really just think about the oxygen. Again, nitrogen comes along for a ride. We don't charge them. We don't charge nitrogen anything, but actually, it's pretty complex in terms of some of the reactions that occur from the nitrogen. But ain't got to worry about it for you guys and gals. But anyway, CH4 burns in the presence of oxygen. Okay, produces carbon dioxide and water. So if you look at this, all right, here's your CH4. Okay, a gas, and your O2 is a gas. Okay, essentially goes out as a CO2 as a gas and water, okay, releases some water. And at the same time, we get the energy out, which is your heat. And that's what we talk about, the heat, essentially the heat of combustion process. It's known as an exothermic reaction. And what you have here is for combustion of methane gas, only the gas, okay, part of it releases about 50.1 kilojoules per gram, okay, of energy from basically from the methane. Now, these values have to be given to you. There really isn't anything in there in terms of the class, or not a class note, the handbook stuff, okay? So if you look at this here with the hydrogen, okay, this is the methane, all right? This is, excuse me, the carbon, okay? If you include the CH4 of the methane, so it's not, this is just the gas part of it, okay? The carbon part of it, okay? And this is with the carbon and the hydrogen. We end up with about 801.6 kilojoules per mole of CH4, which is a 50.4 times 16 grams mole, which is what? What's that there? What's the 16 gram moles per moles? Grams per mole, what? Right, carbon and H4. Okay, molecular weight. Okay, good. Now, the best way that somebody asked me, somebody sent me an email that really the best thing to do. They're in there. They're in the book, but best thing is go to the periodic table to get the individual components. Some of them have the chemical, the chemical equation like CH4, that type of thing. But you got to get them directly. So I get pretty used to doing it. And that's going to be the most. It's going to be where you get most of them. CHs and 4s. When we go back. Oops. See, we got all the different components here, whether it's ethylene, ethane, methane, or whatever, and you can calculate the respective molecular weights. Okay. Oops. Good enough. All right. Now, what you'll also hear a term, okay, that's referred to as the heat of reaction. Okay. We have here the equation, okay? It's on page 152. The heat of reaction, also known as the heat of combustion, essentially, and we'll get into this. We had a little bit of this in the air class. Essentially, what comes out is any kind of combustion process, heat reaction using oxygen, known as the heat of combustion. Principal products are CO2 as a gas, and H2O as a liquid coming out. It's also known under Hess's law. And the equation. That's what this equation is here. If you total up all the products, okay, and this individual stoichiometric coefficient, that's essentially under the amount of moles. All right. And this HF is your enthalpies. All right. And enthalpies here, okay, of the different components. But what's important here, okay, is this value here. If you take the products, you're minus based on the number of moles, you minus off the enthalpy values, okay? And so it's products minus reactants, right? It's under steady state condition. This condition here is 25 degrees C and 1 bar. What's that also known as? STP.